anything to the power 0 is just a fact, is just 1. Okay? So our answer for this first question is just 1. That's just a fact. If it was 6 to the power 0, it would still be 1. Anything to the power 0 is 1. So now our next question here, x to the power 5 over x to the negative 3. We have the same base, so we know a trick that we can do here is we can subtract the 2. That's one way to do it, and that will give you an answer. Another way to do it is I see a negative sign, and whenever you see negative signs, you don't like them, so you want to change them to positive signs. The only way to do that is to move your whole base, base and exponent somewhere else, also known as just above here. On the other side of this division symbol, then you can swap the sign to a positive. So if we did that, it would be x to the power 5, and if I move this all the way up there, I can switch that negative 3 to a positive 3. Those two things are the same thing. So now I have this, x to the power 5 times x to the power 3. Since the bases are the same, we can add the exponents. That's the same as x to the power 8. Alright, so that wasn't so bad, but now we have this type of one. There's multiple ways to do this as well. From the other section, we found out that we could distribute it when we have something like this. When we have two bases or more inside the brackets and an exponent up here, we would have to distribute it to the inside of both of them. Okay, so let's do that. 9 to the power negative 2 over x to the power negative 2. We don't like negative signs, and we have two of them, so let's get rid of them. So let's deal with this one first. If I want to get rid of the negative sign here, I'm going to have to move this whole one to the bottom. So let's do that. So on the bottom, we're going to have 9 to the negative 2, and that, to the positive 2, and the x to the negative 2 is still on the bottom. What goes on the top now that we move that? It's not 0, it's 1. Okay, so whenever you move things around and there's nothing left over, you will always just put a 1. Okay, so what we do here now is we got to get rid of this negative symbol, so let's bring this x to the negative 2 to the top. X to the 2 over 9 to the 2. And now we can simplify it a bit further because we know 9 squared is 81. Okay, so that's the simpler version of that. Now let's go to the next one. Here we have negative 3 over 4 to the power negative 3. So I could do the same thing and distribute that negative 3 to both numbers there. I would also have to do it to the negative sign. That kind of acts as its own base. So there's really three things in there. But one thing you can also do, a different step, is you can see that there's a negative sign all the way out here. We can change that to a positive if we take the fraction and we flip it. Okay, so we can change that to a positive if we take this and we flip it. Okay, if you don't really like that, stick to this method and distribute it on the inside. But I know it's going to be 4 over 3, and now I can put a positive 3 there instead of a negative 3, just by flipping it. One thing to note is negative to the power negative 3. That's kind of hard to realize, but one thing to note is whenever you have a negative sign to an exponent, if that exponent is an odd exponent, that negative sign will stay there. Okay? But if the exponent is even, then that negative sign will go away. Okay? So we know our end answer is going to have a negative sign. So now here we can distribute that 3 now onto the inside, so it's going to be negative 4 cubed over 3 cubed. And 4 times 4 times 4 is 64, and 3 times 3 times 3 is 27. There we go. Alright, so now we're on to E here, which is 25 over 36 to the negative 1/2. So here we can have, let's just go ahead and flip the 2 because there's a negative sign out here, and we'll distribute it to the inside afterwards. So it's the same as 36 over 25 to the power of positive a half. I can get rid of that negative sign just by flipping everything on the inside. So now I can distribute this half to both those numbers. So it's going to be 36 to the half over 25 to the half. And we know half is the same thing as a square root. So it's really the same as square root of 36 over square root of 25. So this will give us what? Square root of 36 is 6. Square root of 25 is 5. So this complicated thing is the same as just 6 over 5. Alright, so that was our fourth section looking into negative exponents and what to do with them. And what you normally do with them is just try to get rid of them. And how do you get rid of them? You swap them onto the other side of a division symbol. Alright, now the last section that we did was nothing too new, but it was combining concepts. So combining fractional exponents and negative exponents and distributing and all those certain things. So now we're going to simplify each. Here, we have 3 questions. We're going to try to simplify them. They look very scary. They have fractions, they have brackets, they have division and exponent there. Okay, so when I see this first, I notice that 7, 7, and 7 all are the same base. Okay, so I know I can do laws to simplify this inside before having to worry about distributing this to all 3 of them. Okay, so I'm going to work on the inside first. I notice that these 2 are right next to each other, so this times this means we can add the exponents. Okay, so let's just do a little side. What's 1 over 3? We're going to add the exponents plus 5 over 3. This is a little bit of a review, but this is going to be equal to, when you add fractions, you leave the bottom denominator the same, and you just add the top numbers. 6 over 3. Okay, so that means we can rewrite this. I'm just going to rewrite the top 2 over 3, and the bottom is now same base, but it's just 6 over 3 because we added those 2. Now I'm going to keep everything else the same. So now it's simpler. I said that 7 1 over 3 times 7 5 over 3 is the same as 7 6 over 3. That got rid of a base. So now we can also see that we have 2 here. Okay, they're the same base and they're on either side of a division symbol, so we can subtract. Okay, which one do you subtract though? 2 over 3 minus 6 over 3 or 6 over 3 minus 2 over 3? The way I do it is I take this exponent, 6 over 3, and I subtract 2 over 3. The reason why I took 6 over 3 and subtracted the 2 over 3 is because 6 over 3 is bigger. I always go bigger minus the smaller one. But I just make sure my result is where the bigger number was. So our bigger number is down there, so my result's going to be down there. So 6 over 3 minus 2 over 3 is equal to, we keep the bottom the same, and we go 6 minus 2 is 4. So overall, I'm going to keep it the same. I just have to know where to put my new base. I know it's going to be on the bottom because the bigger number was on the bottom. And our result was 4 over 3. What do I put up here again? There's nothing left, so I'll just put a 1. Alright. Now once we have that, we have to distribute this 6 to both of those. So now we have 1 to the power 6 over, we have to know what 6 times 4 over 3 is. So let's do that on the side. 6 times 4 over 3. So we're going to change that to a fraction, 6 over 1 times 4 over 3. And with multiplication, you go 6. You do the tops times each other and the bottoms times each other. So this will equal 24 over 3. Okay, 6 times 4 is 24. 1 times 3 is 3. So overall, our one down here is 7 to the power 24 over 3. And then overall 1 to the power 6 is just the same as 1. And then 24 over 3 can be reduced to just an 8, because 3 goes into 24 8 times. And then that's our simplest version. So this complicated thing is the same thing as this simple thing. Okay, so now we're on to B here. This one's not as bad, but it says simplify this one. Okay, so if I look at it, everything's being multiplied together. We have a couple of the same bases there, a couple of the same bases there. This we know can be reduced. 2 goes into 4 twice, so we can change that already. 2 on the top, because it goes with the bigger number. So now I look, and I have a negative sign here, so I want to bring this one to the bottom and switch it positive. So let's do that. There we go. We know with exponent laws, since these bases are the same, we can add those two exponents. So now we can write 2 and b 2 over 3 over a fourth and b 1/3. Last step, we have two bases the same, so we know we can do something there. They're on either side of a division symbol, so we can subtract them. 2 over 3 minus 1 over 3. I subtracted 2 over 3 because it was the bigger number. And I know that'll give me 1/3, and that leaves us with our a4 on the bottom. Okay, so that is actually as far as we can go for that question, and that's the simplest version. A lot more simple than that though. Alright, so last question. This one has something called evaluate, which you do a lot in math, especially later, is you say, what is this expression when you plug in -3 for an a, wherever you see an a, and you plug in 2 wherever you see a b? Okay? So this is really this looks like a complicated expression, so let's try to simplify it first. So here we have a, same base, so we can subtract 6 minus 5. We know we can do that. And 6 minus 5 is 1. Where does it go? It goes on the top because the bigger number was on the top. And we can do the same thing with the b's. 9 minus 8, the bigger number is on the top. So 9 minus 8 is 1. That'll leave us our 1 on the top as well for the b. Can't forget this -2, it's still there. But we've already simplified it quite a bit. Now here we want to distribute this -2 in. We have to bring it to that one and that one, because there's two bases in there. So it's going to be a to the -2, b to the -2. Okay? So those are the same. And now we don't like negative signs, so let's bring it to the bottom. But there's no fraction here, so where's the bottom? If there's no fraction, then we're already assuming it's on the top. And we can swap it like so. So -2, we can change to a +2 by bringing it to the bottom and making it positive. And same with that b. It's going to go down there to make it positive. Alright, so that's the simplest version we can make. So we simplified, but now it says evaluate, which means what is this expression, which is the same as this expression, whenever an a is -3 and a b is 2. So how we do that is an a is -3. You always put brackets like that whenever you're evaluating something. Squared, and the b it's saying is 2. So we put that in brackets, and it's squared as well. Okay, so overall our -3 times -3 is 9. 2 times 2 is 4. And then we can go 9 times 4 is 36. So this complicated expression, whenever an a is -3 and a b is 2, is equal to 1 over 36.